Hello and welcome to this screencast on reflections across the y-axis. We have already established that any exponential function of the form f of t equals ab to the power of t, where a and b are positive real numbers with b not equal to 1, is always concave up and is either always increasing or always decreasing. We have also established that when the growth factor b is between 0 and 1, then the function tends to 0 as t increases without bound, using this arrow notation as shorthand. And when the growth factor b is greater than 1, the function increases without bound as t increases without bound. Lastly, we've established that the constant a is a vertical scaling of b to the t, and so the y-intercept is at 0a. From our previous study of transformations, we also know that when a is less than 0, the graph is reflected across the x-axis. In a future video, we will specifically identify how transformations across the x-axis affect the graph of f of t equals ab to the power of t. But in this video, we will focus on reflections across the y-axis. To explore reflections across the y-axis, let's look at p of t equals 2 to the power of t and q of t equals 1/2 to the power of t. Looking at their respective graphs, we can see that q of t is a reflection of p of t across the y-axis. In addition, we make a key observation about the use of exponents. For the function q of t equals 1/2 to the power of t, there are three equivalent ways we may write the function. We say 1/2 to the power of t equals 1 to the t divided by 2 to the t, which equals 1 over 2 to the t. And we can say that 1 over 2 to the t equals 2 raised to the negative t power. In other words, q of t can be written as q of t equals 2 raised to the negative t power. Therefore, we can say that the graphs of p of t equals 2 to the power of t and q of t equals 2 to the power of negative t are reflections of one another in the y-axis. In fact, this can be generalized to all functions. It is always true that y equals h of negative t is the reflection of y equals h of t across the y-axis. We see this verified below. b of x equals 3 to the x power is in blue. By composition, we know that b of negative x equals 3 raised to the negative x power. And we see that b of negative x is a reflection of b of x across the y-axis. So far, we have looked at vertical scaling and reflections across the y-axis of f of t equals b to the power of t. In the following videos, we will explore how vertical shifts and reflections across the x-axis affect the graph of f of t equals ab to the power of t.